This is Mr. Hassan's Maths channel. I'm now answering question number 10 from the June 2022, the GCE UK A-level paper 9MA02. This is the paper 2 from that syllabus, and this is basically a question which relates to P3 in the international A-level syllabus. This is what I'm teaching and I prepare my students for. And this question relates very much to that, so I'm taking questions from this syllabus that relate to the international A-level. Okay, they're very much similar actually, but this is in P3 of the IAL. And this is about functions. And here we're given a function which is defined by f of x equals 8x plus 5 over 2x plus 3. And we're given a domain. We're given this, which is really important for us to understand. Okay, this is the domain of the function. So this function, f of x, only exists for x values which are greater than -3/2 in this case that they've given us. That's not written there just to make the question look nice or to make it look confusing. It's there to give you some information about this function. This is the domain of the function, and it does affect our answers which come later on. It does definitely affect our answers. So it's something that we have to be very much aware of. It's not just given there for no reason. Okay, that's something which we have to be very much aware of here. Now, the first question says, find the inverse f(3/2). So it's basically saying, find the inverse function f of x and then substitute 3/2 into it. And that's like what many people would do. They would find the inverse function first, okay, by making y the subject, first making y equals 8x plus 5 over 2x plus 3, and then they would change the x for the y and make the y the subject, and then once they've done that, that will be the inverse function, then they will substitute 3/2 into that, and that's fine if you do that. If you find the inverse function first and then substitute 3/2 into it, that's perfectly fine. But there are a few shortcuts that we can use. Here, we're not actually asked to find the inverse function at all, right? Algebra, in terms of x. So a quick way of answering this question, which would be worthy of just the 2 marks that it's worth, would be to think of a different way of doing it. Okay. Now, basically, what happens is, if you're asked to find f(3/2), you ask yourself, what would you do? Okay, so if you ask yourself what you would do if you're trying to find f(3/2), you would replace the x with 3/2. Okay, now this function can be rewritten as y equals 8x plus 5 over 2x plus 3. Right? So when you're trying to find the inverse, if you remember, when we're finding the inverse, it's like we're swapping the x and y's around. The inverse is like the x-axis becomes a y-axis, the y-axis becomes the x-axis. It's a reflection of the line y equals x. Y becomes x becomes y. So instead of replacing the 3/2 with the x, when it's inverse, we do the opposite. So this would mean replace the x with 3/2. That's what it means. Okay, but when you have the inverse, you change the x for the y. When it's the inverse, you replace the y with 3/2. So now if I replace the y with 3/2, I have 8x plus 5 over 2x plus 3 equals 3/2. Now that, when I solve that for x, it's going to give me my answer. It's going to give me the value of f inverse 3/2. My answer will end up being what we're looking for. The x value I get from this will be my answer, will be the value of this. So I'm going to now cross multiply. So 2 times this, that's going to give me 16x plus 10. And 3 times 2x plus 3, that's going to give me 6x plus 9. Okay, when I say cross multiply, we basically multiplied both sides by 2/3 to get rid of the fraction, and also multiplied both sides by 2 and multiplied both sides also by 2x plus 3. When we multiplied both sides by 2, this 2 cancelled out and you multiplied it with this. And when we multiplied by 2x plus 3, this cancelled out and you multiplied with that. Basically, that's what cross multiplication actually really is. So now when we solve this, we're going to do 16x minus 6x equals 9 minus 10. So we're left with 10x is equal to minus 1. So x is going to be minus 1/10. So therefore, we can say that the inverse of 3/2 is equal to minus 1/10. That's a much quicker way of getting to the answer. then finding the inverse function and then substituting 3 over 2 into that. It's way quicker than doing that. Okay, I can show you to make sure if you want to. In fact, I will do that. I will take this function and I will show you how to find it in the other way. So I will take this from here and I'll use a blank page here. And see the traditional way that most people would, or a lot of people would do, they'll say, let first call f(x) equals y. So you have y equals 8x plus 5 over 2x plus 3. And then they would say, replace the x with the y and the y with the x. So that becomes 8y plus 5 over 2y plus 3. And then they would make y the subject. So again, we'd cross multiply. So we'd have 2 times xy plus 3 times x equals 8y plus 5. Now we want to make y the subject, so we're going to subtract 8y from both sides and also subtract 3x from both sides. And then y you take out as a factor, so you have 2x minus 8 equals 5 minus 3x. And then you have your y equals 5 minus 3x over 2x minus 8. And that's your inverse function in terms of x. 5 minus 3x over 2x minus 8. So then what we have to do is we have to substitute 3 over 2, because remember our objective was to find inverse f of 3 over 2. So we have to substitute this into the inverse function. So instead of x, I'll write 3 over 2. So you have 5 minus 3 times 3 over 2 over 2 times 3 over 2 minus 8. Replace the x with 3 over 2. So you have 5 minus 9 over 2. 5 minus 9 over 2 divided by 2's cancel, 3 minus 8. That gives you, that's 10 over 2 minus 9 over 2. Okay, which is 1 over 2. Okay, that's 10 over 2 minus 9 over 2, which is 1 over 2, over negative 5, which is a half, divided by minus 5, which is the same as a half, times minus 1/5, okay, which gives you minus 1 over 10. So that gives you minus 1 over 10. So we can see that the inverse of the function, when you put 3 over 2 into it, is negative 1 over 10, which is exactly what we found when we did it the other way. This is a lot longer. Okay, it's still correct. You'll still get the 2 marks, but it takes you a lot longer. So if you understand that what we are doing when we are finding the inverse function is actually we're swapping the x and the y, as you can see, that's exactly what we did here, then we can do this in the way I've shown you over here, where we just, instead of, when we have the inverse function, we think about first, what would we do if the inverse wasn't there? We would replace the x with 3 over 2. But because it's inverse, we replace the y with 3 over 2 instead, and we solve for x, and the answer we get is our value of the inverse of that number. So there's the answer for part A. I showed you the other method just to give you a complete understanding. All right, you don't have to, of course, do that way. Now, for part B, it says, show that f of x is equal to a plus b over 2x plus 3, where a and b are constants to be found. So basically, they want to split this improper fraction into a mixed number. So we have f of x equals 8x plus 5 over 2x plus 3. So we start off with f of x equals 8x plus 5 over 2x plus 3. So you want to split this into this form here. Okay. Now, one of the things we can realize straight away is that when you divide the x terms, first of all, this is an improper fraction. It's an improper fraction because the order of the numerator is the same as the order of the denominator. I'm not talking about its value when you replace values with x. I'm talking about its order. In terms, the order meaning the highest power that you see. So here the highest power is 1 on the numerator for the x, and the denominator is also 1. So as long as the numerator has an order which is equal to or greater than the order of the denominator, it is considered an improper fraction. Now, if the orders are the same, then if you want to write this as a mixed number, you're going to have a constant as your whole number part. Just like when you have, for example, 5 over 4, you have when you write this as a mixed number, you have your whole number part, which is going to be 1, right? In this case, I know the whole number part is going to be 4 because you have 8x over 2x. When you divide the coefficients of x, the x's, you'll get the whole number part when they have the same order. And then you'll have plus b, the remainder, over 2x plus 3. Just like here, you have the remainder, which is 1 over the original denominator. That's a mixed number. It's actually originally 1 plus a quarter, which you write as 1 1/4. Here you have a plus with algebraic fractions. You have to put the plus, b over 2x plus 3. So we need to find the value of a and b. Now, I know the value of a is equal to 4 because 8x divided by 2x gives me 4. Okay, so I know that's 4. We've got to find what b is. Now, there's lots of ways you can use to find the values of a and b here. One of them is by using long division. One of them is by rewriting the numerator. If you use long division, you just do 2x plus 3 into 8x plus 5. 2x goes into 8x 4 times, as I mentioned. 4 times 2x is 8x. 4 times 3 is 12. When you subtract them, you have 5 minus 12, which is negative 7. So you know that b, that's the remainder. Okay, so you're going to end up with b equals negative 7. That's the remainder there. So this is going to become 4 minus 7 over 2x plus 3. That is the function f of x. Okay, simple as that, right? We could also do this in another way. Another way is by what's called rewriting the numerator, which is a nice way of doing it as well. So what I would do is I'll write the denominator as it is, and I'll rewrite the numerator so that it matches the denominator first. So I'm going to just, whatever's in the denominator, I'm going to copy it into the numerator. And then I'm going to ask myself, how does that 2x become 8x? Well, it's multiplied by 4. That's how 2x is going to become 8x. You multiply it by 4, it becomes 8x. Now, this will give you 4x plus 12. I want to end up with a 5 here. All right, so how does 12 become into 5? Well, you have to take away 7 from it. So if you take away 7 from this, that's going to give you 8x plus 12 minus 7, which is 8x plus 5, exactly what we have here. Now we can split this into 2 parts. We have 2 separate terms. We can write this as 4 times 2x plus 3 over 2x plus 3 minus 7 over 2x plus 3. The 2x plus 3's cancel out, and you're left with 4 minus 7 over 2x plus 3. So we have basically, done the same thing. We found the values of a and b. A is 4, and b is negative 7, and we've written it in this form where it's now a mixed number instead of an improper fraction. So it's an algebraic mixed number instead of an algebraic improper fraction. So that's how we can answer B. There's a couple of different ways I've shown you how to do that. I personally like to rewrite the numerator when it's something simple like this. Okay, so now for part C. It says the function g is defined by g of x equals 16 minus x squared. And again, they've given us this little information next to it. That's telling us what the domain of this function is. This function only exists for x values between 0 and 4, including 0, including 4. That's the only values of x for which this function exists. So we've got to state the range of the inverse function of gx. Now, one of the things we should realize, as we mentioned just before earlier, that when you have the inverse function, the y becomes the x and the x becomes the y, right? So the domain of a function is known as its x values, the x values it can take. And the range of a function, like the output of the function, is like the y values. So the domain is like the input, the x values, what goes into the function, and the range of the y values like the output of the function. So when you're dealing with an inverse of a function, okay, the inverse of a function, okay, the domain of the normal function becomes the range of the inverse function. And the range of the normal function becomes the domain of the inverse function. Right? The domain and range switch around. So if this is the domain of the original function, therefore the range of the inverse function is going to be the same as this, but be very careful. Okay, be very careful. You don't write x, you write y, because now we're talking about the y values. The range is the y value. So we don't just copy it exactly as it is. The x becomes a y because the range is the y values of the function. Okay, so that's very, very important for us to realize. So we can just write the answer down. It's just 1 mark. It says state the range, nothing to show, no working to show whatsoever. You can just write down the range, but be careful not to write X. You must write Y. Now, just for your better understanding, you don't have to show this at all. I just want to show you how this basically works, right? So don't think you have to show these steps. I just want to, as I said, I like to give you a bit of a deeper understanding, just to make sure that everything's understood properly. So if I was to draw this function, okay, the original function, g of x, 16 minus x squared, that's a quadratic. It's going to be upside down like this if you draw it as it is. The vertex is going to be at 16. Okay, that's the vertex at 16. And where does it cross the x-axis? Well, it would cross it in at -4 and +4, because x, when y is equal to 0, you have x squared equals 16, so x equals plus or minus 4. But because this only exists between 0 and 4, it's only going to be on this side. So the actual function, if we were to draw it fully, it would go like this. But because we are starting at x equals 0, it's going to only exist between 0 and 4. So that will be 4 here, and that's 16 there. Okay, that's 4 here, and that's 16 there. Now, the inverse function, okay, the inverse function is where they swap around. So the inverse function would go through 0, 4, and it would go through 16, 0. So the inverse function will look something like this. Okay, and it's not drawn very well, but it should go through. That should be y equals x. I haven't drawn the scales the same, so that's why it doesn't look so good. It should really go through. It would really go through. The y equals x would go through that point where they intersect, because it's a reflection in y equals x. Okay, so this would be the inverse function if we were to draw it. The inverse function would look like this. This would be the inverse function. Okay, this one over here. And you can see the range of the inverse function are the y values it can take between 0 and 4. Okay, between 0 and 4. That's the range. You can see that from the graph, hopefully. So that's just a little side point. You don't have to draw this at all. I just wanted to make you see what's happening. Okay, and you can see that the inverse is the reflection of the original in the line y equals x. Okay, so that's something that's a little bit of a side point for us. And now I'm going to move on to the next part of the question, which is actually something where I really want to go through it in some detail. Okay, it says find the range of f, g inverse. So the range of the composite function, get me back the right color. Okay, of f inverse of g of x, basically. So basically what this means is, when you have a composite function, what comes second goes into what's first. So this is like f of g inverse x. So it's when you substitute the inverse function into the original function. And we want to find the range. They're not asking us to find the actual algebraic expression for it. We don't need to do that. We could do that if we wanted to, but we don't need to do that. Okay, what we need to do is to think about what the output of this is going to be. What is the output of this? Okay, now, what's basically happening is we're taking something and we're putting it into into g of x. Okay, so you have x going into inverse g of x. This is going into the function inverse g of x. So the x values go into the inverse function of g of x, and then what goes into what we get from that will then go into the function f of x. That's what's happening. Okay, so that goes into f of x. All right, so we got to think about what is able first. What are we able to put into g of x? Well, we know that the inverse of g of x, okay, its domain, okay, is basically the same as the range of this function. Okay, so the domain of inverse of g of x, okay, what is able to go inside the inverse of g of x is going to be basically all the values of what can go into there. If we go back to our graph that we drew, the range of g of x was 0 to 16. So that's going to be the input that you can put any value of x between 0 and 16. That's what can go into this function for the inverse function. Okay? And what comes out of it is value of x between 0 and 4. That's what comes out of this function. So this is the input and this is the output. So when you put this into here, what comes out is values of x between 0 and 4. And it's this that goes into the function f of x. This is what can go into the function f of x. The output of the inverse function is what goes into f of x. So the output of inverse function g of x is the values of x between 0 and 4. We can say the values of y between 0 and 4 actually. Okay, but those are the x values that go into the function f of x. Okay, so what goes into f of x? Any values between 0 and 4. So what will come out of f of x? Well, let's see. When 0 goes, if we think about this function f of x, okay, we got to think about how it looks. So I'm going to do a little graph. Now, we were asked to rewrite it, which kind of helps us a little bit. Okay, we were asked to rewrite it. So we're told that this function f of x, and we wrote it as, if we think about how we rewrote it, we said f of x is equal to, it was 4 minus 7 over 2x plus 3. So we mentioned that there are two, this is a reciprocal function, as we know. And there are two asymptotes. You have the horizontal asymptote, which is going to be when y equals 4. Okay, let me just put that here. That's the horizontal asymptote, y equals 4. Okay. And we have the vertical asymptote when x, the x value that this can't take is when x is equal to negative 3 over 2. We probably don't have to worry about that because our domain doesn't include that, but I'm just showing you that would be negative 1.5. Whatever value makes this 0 is going to also be an asymptote. So this would be an asymptote if it could be part of our function x equals minus 3 over 2. All right. Now we're told that x is greater than minus 3 over 2, so we don't have to worry about this other side. But what we can realize now is this function, okay, because it has a minus in front of this, it's like negative 1 over x of that form, it's going to exist on this side. And we can see that when x is 0, y is 5 over 3, so that kind of makes sense. It's going to go something like this. This is how this function would look. Okay, now, we see that this would be the function f of x, y equals f of x. It would exist from when x is greater than minus 3 over 2. However, what we put into f of x is the inverse of g. So the domain that we have to deal with is between 0 and 4 only. So what goes into our function, okay, the output of this depends on what can go into it. And what can go into it? Values of x between 0 and 4 only. So I've got to get rid of everything before this, and I've got to only go up to x equals 4. So everything on both sides of this have to go, because my domain is only values of x that are allowed, that are the output of inverse of g of x. So whatever comes out of this, okay, is what can go into the function f. And what can come out of this is values of x between 0 and 4, because the output of the inverse function is the same as the domain of the original function, as we just mentioned before. So therefore, we can only take values, okay, of x between 0 and 4. So I've got to find what is the y value here and what is the y value there, and that will be my range. So I've got to substitute inside my function f of x, which is easier to write as 8x plus 5 over 2x plus 3. So my limits are going to be when x equals 0. So I'll put f0. That's going to give me 8 times 0, which is 0 plus 5, which is 5 over 2 times 0 plus 3, which is 3. So that's going to be my x value over here. So this is when x is 5 over 3, and that value there is going to be when x equals 4. So when I put x equals 4 into this function, I'm going to get f4 equals 8 times 4 plus 5 over 2 times 4 plus 3. That gives me 8 times 4 is 32, plus 5 is 37, over 2 times 4 is 8, plus 2, which is 11. Okay, so that is the value 37 over 11. 32, yeah, 37 over 11. That's the value over there. So my range, okay, you can say y is between, and it's equal to both of them because these are both, equal to. Okay, so my range is between 5 over 3 and 37 over 11. That is the range of my inverse function, of my composite function. That's the range. Now you can write that as y. You can also write that as f inverse g of x is between 37 over 11 and 5 over 3, including both of them. So that's the answer here. So it's very important for us to understand how to deal with a question like this. We have to think about, we can't just think about the domain of this original function. We've got to think about the domain of what, the range of what goes into it. Because what can go into this is the output of that. What is the output of that? It's values between 0 and 4. So that will be the domain of this function. That's what can go into this function. So the domain, the range of this inverse function is between 0 and 4. Why? Because the range of the inverse is the same as the domain of the original, right? So that's what would come out of this function here. Any values of x between 0 and 4. You can't have anything less than 0. You can't have anything more than 4 because of the restriction of the original function. So only values of x between 0 and 4 can go into this. So when we look at our graph, we can see that, it looks like this between 0 and 4. So we know that the range will range from 5 over 3 up to 37 over 11. Okay, those are the values that came out. And that concludes this question number 10, part D. Okay, this is very important, especially this last part D. Some students were asking about this particular issue, and I'm going to do a few more questions on this. I'll try to find a few more questions. It's kind of newish, this kind of concept, and I'll do a few more questions to hopefully make this whole concept a bit more secure. Thank you for watching. Other questions from this particular paper, this Edexcel UK A-level paper, can be found in the playlist that will appear over here. This is from June 2022. Other questions that are dealing with, functions, inverse functions, graphs and functions can be found in the playlist that will appear over here. You can subscribe to my channel by clicking on this link over here, and you can watch a video, which the link will appear here, which tells you how to use my channel in an efficient manner. Thank you for watching, and see you soon.